And hello everyone, welcome back to another Nim tutorial. In this tutorial we'll be taking a look at pragmas. Now a pragma is a way of giving the compiler more information, and they are oftentimes enclosed in these. So you might have seen them around a bit even in our tutorials, because they oftentimes find place in these little brackets and dots. So let's use one as an example. Let's say we have let my var, and this is just a variable which is of type string, and we can just say some important variable. Now as your code grows, or your library, or whatever you are building, there may be things that you want to phase out of your code in the future. For example, let's say you created a really slow addition function, or in this case a variable that does not contain important information anymore, or that should be found somewhere else. In that case you want to mark it as deprecated. Now what deprecated means is it is a function or a variable or whatever you're marking as deprecated that should no longer be used and will in the future be removed. So here we could just say deprecated. This will mark this variable as deprecated. So now if I were to echo out my var, first you'll notice we get like a little yellow line here which says my var is deprecated. So it tells you before you even compile the program that hey, what you're trying to use right now should probably not be used. But this will still run and compile as expected. So if we go here, you can see we still get some important variable being thrown out here, so you don't have to worry about it. It is just pretty much for the user to know that hey, you should probably not be using this anymore, there are alternatives. Another example could be if we were to create a no use procedure, and we can just make it equal to echo this should not be used anymore. So just any value you can think of should go in there. And of course we can call no use without an issue, it will run perfectly fine. This should not be used anymore. But if you were to want to deprecate this, you can add your deprecation right here. However, oftentimes it is highly recommended that if you deprecate something, to provide the user with an alternative if there is one. For example, oftentimes with functions, if it's deprecated, let's say it's a library, you want to redirect the users to the function you want to use. When you don't do this, you kind of force them to go and look for it in your documentation, which many developers are lazy and they will not do, and they will just keep using your deprecated version of your software as well as the deprecated functions because they're just too lazy to go find it themselves. But you can specify what they should be doing instead by going use my func instead. And now you're telling them when they hover over it, hey, this is deprecated, and my bad, I forgot to put a colon there, so deprecated colon. Now you're telling them, hey, this is deprecated, but you can use my func instead. Now instead of having to go all the way and search through things, they could just know, okay, I would instead use my func. Then they call my func instead, which is not deprecated. So this is the recommended way to handle deprecations. It is to give either a reason for its deprecation, or even better, an alternative to use instead of this. And of course, again, this will compile just fine. It won't throw any errors. Alright, so let's say we have a calculation program, procedure calc1. Calc1 takes in an x and a y value. It returns an int, and then of course we can just return x plus y. Now if we were to call calc1 10.1, and we can even echo that, it will run perfectly fine as normal. However, this right here has no side effects. Now what exactly is no side effects? Pretty much a no side effect procedure, or in NIM's case a function, is that when its output only depends on its input, which also means it does not modify or access anything out of its scope. And as a refresher, this is its scope. Everything indented inside of it is its scope. So if I were to say let x is equal to 10, or maybe not X, let's go Z, and I were to use Z in here for whatever reason, then this now has a side effect because it affects something outside of its scope. Another side effect is also input-output operations. This includes printing, reading files, and modifying global variables. Again, nothing outside of its scope should be modified. And we go echo here, then this is also considered a side effect. So let's say we want to make this a no side effect. In this case, we can just go here and say no side effect. Now this will complain because we have multiple side effects currently happening. Echo, this right here is a side effect. So it says, hey, calc1 calls no side effect, or calc1 calls a side effect, echo, because this is marked as a side effect. Remove that. But still we have another one. If you hover over here, calc1 accesses global state Z, which is also considered a side effect. So we remove that. Now we have a procedure that has no side effects. It is as pure as it can get. Now Nim knows that a lot of people prefer no side effects in their code whenever possible. So they provided us with the func keyword. That's why there's a difference between func and procedure in them. Even though I use them interchangeably, I should actually most of the time be saying procedure and not function, because a function is a procedure without any side effects. So it does not need this right here because it is already no side effect. So if I say echo test, it's going to complain because echo is a side effect. So it's somewhat of a syntactic sugar to just get rid of that pragma, which it now provides automatically. So you get rid of that no side effect pragma that you have to type out the whole time. Now, let's say for interest's sake, you do in fact want to use a side effect inside of your no side effect procedure. Let's say a good reason for this would be debugging. Then you could provide a cast and just insert no side effect. This means for the next line, just ignore side effects. So echo, this can now run. And of course we need a colon, otherwise it wouldn't quite work right. There we go. So now we are casting the no side effect here. So we're saying, hey, okay, for the next line, just ignore it. This is great if you want to do some debugging, because if I were to now run this, it can say, hey, this can now run, and it still gives us our output. However, this again has its time and place. This does negate a ton of things Nim does in the background, so you don't really want to use this too often. So this should pretty much just be used in case you have a no side effect thing and you just need to quickly add a side effect for whatever reason. Next up, let's go and create a procedure, and let's call it warning. Warning will just echo out, hello, warning ahead. That is nothing too complex. If we call warning, there we go. If you run it, it runs like a normal program. Perfect. Now we can add a pragma here that will show a warning during compile time. It will not stop the compilation or anything. It will just simply show a warning. So if we go here, warning, this is a warning. And if you don't call warning, it will still warning us. So if we will go here, I just put hints off so we don't get all of that other stuff. It will actually say warning, this is a warning. So this will run even if you don't call the procedure. So during compile time, if it sees this warning, it's going to throw it. So take note that this can be confusing. So if you were to say, this function is very slow, and you run this, people won't really know what you're talking about unless they go to this line and column. So just take note that it can be somewhat confusing, so just make sure to specify what you're throwing a warning about. And of course you can still call it, it won't give any errors, it will still run perfectly fine. Similarly, you can have hints. So if we go here, hint using warning is kinda confusing. And there should not be hit, there should be hint. Alright, if we run this, we'll see we actually don't get the hint because we turned off hints. So to see the hint, we will need to turn on hints. So if we take a look here, let's compile it back. Actually, let's remove the hints thing entirely. There we go. Now we get the warning, as well as the hint that we provided. So using warning is kind of confusing, and in here the function is very slow. So you can do this to maybe give whoever's compiling this some information they might be interested in hearing. Alright, so now let's create another calc. Again, it will just take an x and y, which are both int, return an int, and then of course return x plus y. If we echo out calc, again it will work as expected. There we go, free. Alright, now let's say that you do not want people calling this function. Similar to deprecated, but you want it to be more strict. So you want them to go, okay, we are not going to let you run this function. This function should not be called. What you could do is you could go error. Now, note that this function can still be compiled. If we were to do this, as you can see, it still compiles. But the second we try to run this function or procedure, then we actually get an error. Usage of calc is an error defined at and wherever. So this will actually give us an error when we try and run this. So take note, when you provide an error, it can still compile the program and it can still run the program. But the second you call that procedure, it will end the program. So just take note of that. And by end, I mean it won't compile it. So just take note, it doesn't stop compiling unless you call it. Now, if you are really serious about something just not being used or being done, you can, instead of going error, go fatal. This is not good. There we go. Now what fatal will do, as you can see, is already giving us a big red here. Fatal will make sure the program does not compile at all while this fatal is in there. So when we try and run this, we're going to get a fatal error. This is not good. So fatal, unlike error, error will still compile fine. It's only when you call it where it will throw an error. Fatal will never compile. It will just say no way. Now you might be wondering, okay, but if I can't compile my program anyways, what is the point of fatal? Now fatal is good for compile time checking. For example, when nim major, which is the major version of nim, so if I were to go nim -- version, you'll notice I have nim major version 2, minor version 2, so 2.2.0. So when nim major is less than, let's say, 3, we can fatal, you need a higher version of nim. Maybe when you actually code something like this, just make sure to specify what version of nim. You'll see we get this fatal, and if we try and compile it, we get that error. And this should have a colon, my bad. There we go. However, if we were to make this less than 2, you'll notice the error actually disappears and the program can compile and echo hello, run without any issues. So this right here is a compile time check to make sure, hey, do you have the right nim version to even run this project? If you don't, throw an error. You can even go, if you need a really specific one, nim major, if that is equal to 2, and nim minor is less than 2. So if nim is version 2, but the minor version is also important, you can say if it's less than this version here, also throw an error. So if I were to go 3, we'll get an error because I have nim version 2.2. So I'll need nim version 2.3 to run this piece of code. Run this, you know we get an error. If you do this, we don't get an error. This has other useful use cases as well for, let's say, const use advanced feature. Let's go there. And this is equal to true. So let's say they try and compile the program when not use advanced feature. So if this is false, then we want to just go fatal. This feature must be compiled. Must be true to compile. And again, we can echo without any issue. We run this, it goes perfectly fine, but if we make this false, and this when is a during compile time check, then here we go and get that error. Fatal has its time and place, however you should not be trying to use it for runtime errors. For example, a division by 0 is a runtime error. If the user inputs 1 and 0, or even the developer, and it compiles and runs that, that's a runtime error. A compile time error is when we compile the program, not while the program is running. So best use is to just use Fatal for compile time errors. For runtime errors, you can use raise, which we'll get to in a future video. Raise pretty much just raises an error during runtime. Alright, and that is the basics of pragmas in Nim. Thank you all for watching. I hope you all enjoyed. And I will see you all again in the next video.